All right, welcome back, everybody. So this is a follow-up to a video I made last time titled "What is Project Management?" And there's actually going to be a subsequent follow-up to this one, which is "What is Quality Management?" And that next video will be titled "The Tuckman Model of Group Development," just to help paint a better picture of what it's like to work in groups and the experience of the individual as well as of the collective. But without further ado, let's get into today's session of what is quality management. So again, none of the photos I've got on here are sponsored photos. This is all my original work, yada, yada, yada. So the goal of today's presentation is really to help you better understand exactly what is meant by quality. And there are a few definitions, some formal, some more informal, to help you understand just what exactly quality management is. A lot of folks might have heard talk of quality, especially folks that work in the health sciences, but there is actually a universal definition and explanation not only of what quality is, but how to properly manage it, regardless of what the project management environment you're in, right? So you can be in the traditional style of sequentially, waterfalling projects, or you could be in a more hybrid and or follow a more pure agile method of doing work. Regardless, though, quality plays an important role, and we're going to talk about that. You're going to be able to learn exactly just who is responsible for quality. It is, in fact, a difference between, if you remember from our last video, responsibility and accountability. You're going to be able to learn how much quality costs, and I'll give you some other resources you can follow up on your own so you can better educate yourself and your peers. So let's get right on into it. Now, just what is quality, right? The formal definition, right, is the degree to which a set of characteristics fulfill requirements. And for requirements, sometimes we might hear of requirements given to us by our customers. Sometimes we, as the producer or vendor of a particular product or service, know there are certain requirements the service or product needs to have built into it to even be able to be sold. There's also legal requirements. So that word, the keyword there is requirement, but really, when we talk about the more practical layman's term, it just simply means a conformance to specifications, right? So if it's a particular grade of aluminum or a particular grade of steel, depending on its application, right? Those specifications need to be met in order to be fit for use. Similarly, if it's a particular drug or a particular batch of chemistry, there's a certain percentage of a catalyst need necessary to be present, or a certain percentage of particulates that it needs to meet in order to adhere to some sort of cleanliness specification. This is especially true in the semiconductor industry. And really, the important takeaway here is that regardless of what the exact specification is, if it's for a product or service, it spans every part of every project, every individual, and throughout the entire organization, and every future project that ever will be. And the cool thing is, it's always free, always has been, and always will be. And those are actually not my words. There's this gentleman by the name of Phil Crosby who really worked as a statistician and an engineer for ITT. And he really laid the foundation of just what quality means, what it looks like when quality is not present, not only on the technical engineering aspect, but also on the cultural side. And it's the best takeaway that we've gotten from Crosby's work is that quality really is a mindset. It's also a tangible product, service, and result, as well as a process. It's not what was originally thought just to be we have this particular wheel and say we make the best bearings for that wheel because we use the highest grade steel and that's forged or cast in a particular way. That's not necessarily what quality is. It's important, just as equally important to understand the processes, both on the engineering side as well as on the business procedural side that go into making it. And even more importantly, not everything has to be of high quality. For example, the eggs we frequently purchase at the grocery store, there are some higher grade eggs, but there are also lower grade eggs that people can buy, oftentimes for a lower cost. And really, the difference is for eggs in particular, whether you can see if you put it under, I believe it's just any old white light, if you can see spatterings of blood clotting in the egg versus ones that you cannot. And the ones that are sold to us are the ones that do not have it. And it's not that it's any less healthy, it's more of a visual appearance. And another way we see this is plastic fasteners on, say, a particular set of hinges for a toy that a kid will use that, doesn't necessarily need to be as robust as, being made out of cast iron, for example. Um, so it's not the case that you have to have high quality for everything, right? And for everything, I mean a process, a good, as well as a service. Um, Something else I wanted to mention here is that the characteristics of what we use to define quality are progressively elaborated. This actually speaks to both environments, agile or waterfall, where we iteratively go through to better understand the needs of our customer, the arising issues as we are conducting project work by communicating with our fellow project team as well as stakeholders who might either be sponsors or simply people that just have an interest in the project. We have conversations on an ongoing basis with these folks proactively. And again, if we go back to the definition of who's accountable for doing this, it's the project manager. But everybody is responsible for ensuring that we engage in this progressively elaborative manner. Another point here is that uh, the expectations and scope of resources are of equal importance. And as you go through the progressive elaboration method, you realize that not everything needs to be of a particular high quality, and not everything needs to be um, y- uh, those specifications you don't need to necessarily figure out right then and there. So you will figure out a lot of those things, not just the issues you have, but should we even design this particular thing or not as you interact with your peers. What is quality management? So again, we talked a little bit about this before. It's, equal parts the product itself. It's also the process used to actually make the product or actually deliver the service, right? Like for example, if you're doing, a financial audit and the only person you ever talk to verify data is, say, just one chief accountant without talking to some other procurement folks, then that is, not a good approach as far as quality is concerned because you have just one point of contact and there's a lot of potential for skew and bias present there. Um, Quality management is really about taking a proactive approach to quality, which means you are essentially working to prevent an issue, even if it's something that you have not built yet. You are taking preventative steps so that at some point when you do build it, you avoid issues. One area we see this is the multi-layered security approach to safety in the aviation industry. right? An ounce of prevention is worth a pound of cure or something like that. I forget exactly how the saying goes, but prevention is your best friend when it comes to quality. What Crosby also really showed is what really matters at the end of the day is how things are actually conducted far outweighs as a contributing factor to your overall quality than what you produce. Meaning, you can have the world's smartest folks working on building airplane wheels. I don't know why I'm so fascinated by airplane wheels today, but I guess we'll just roll with it, pun intended. And the interesting thing is it doesn't matter if you have the best type of materials, you are experts at galvanizing, you are experts in petrochemicals, and you really know your your ability to mass produce and even batch produce various synthetic rubbers. It does not matter. What matters is how the folks, the humans, as well as the machines, all come together, as well as the business processes to actually produce said airplane wheels. And the reason why that is the case is because you can have anywhere along that line, a number of steps essentially go wrong, but still end up producing an airplane wheel. However, it might not last as long. It might actually only be able to go to a certain level of elevation, or it might be fit for use in only certain aviation standards as opposed to flying commercial airplanes all day and all night. It really depends, and that is why the way in which you actually produce something is far more important in terms of quality than what you're actually producing. The really biggest thing to the digest in this is that the company as an organization bears most of the investment of the cost of quality, not individual projects. And that just makes sense, right? If you imagine a company, which is every company, as they're trying to innovate and they are trying to and then the way you do that is you take on new initiatives, again, remembering how a strategy impacts a portfolio, impacts a program, impacts a project. You simply cannot have one project essentially bearing the burden of all of the costs of quality because it just simply would not be cost effective to ever run projects at that point. So the cost of business is simply that overall, whether you want to or not, there is a level of financial burden the organization as a whole takes, especially for new initiatives, because it's not just that it's not tried and tested as far as a product or service goes, but how we actually deliver it is really at the crux of um, the biggest investment and spending that you'll make. And when we talk about quality management in traditional waterfall environment, there's actually three processes that go into completing the quality management cycle. There's the planning quality management, which is actually creating the quality management document. Then as we carry out work, we are iteratively managing our quality. And again, management is a level of preventative uh, approach, whereas controlling quality, it's not that it's a unnecessary or a lower level of work, but it's simply to say that there will be times as we are trying to maintain a certain level of quality where we'll have to use what's called a retroactive approach, which we're controlling quality by means of inspection, which is after the fact it's made. Who is responsible for quality? So again, everyone without exception. Some of the new ways of thinking today, when we talk about total quality management, really highlights this. And the key thing to understand really with total quality management, again, is that it's the shift away from the product itself that's produced, and really instead looking at the underlying process of how it was produced. Um, Culturally, too, uh, Crosby also highlights this in his work. Quality requires a philosophy of long-term, not short-term commitment. And notice there, I did not say profit. The level of commitment and effort required to ensuring a higher grade of quality overall as an organization, not just for one or two particular product lines, is that you're really looking to retain a customer base, reduce your level of churn, not just for customers, but employees overall. And this is because, again, looking back at the fact that quality is free, regardless of what you're making and how you're producing it, even though you might not be paying that cost right up front as you're producing it, you absolutely will at some point down the road. It is inescapable, it is inevitable. It is something that is absolutely guaranteed at every point in time. And the level of cost you take on can in fact be pre-planned. So if you do decide, for example, to make a costly business decision that, while it might not be best in the long term, you have planned for it as a business decision overall in the grand scheme of things. And that's a key important factor there, where it's not like you have to always strive for utmost perfection, and if you miss it at any point, you're automatically screwed. No, actually, quite the contrary. You can absolutely make those decisions, but they have to be conscious. They have to be totally conscious decisions. What I mean when I say conscious is your entire organization as a whole needs to be involved, even if it's as little as informing your stakeholders, and your stakeholders again are far more than just board members and C-suite executives. It is also your production staff, right? Operators, engineers, shift supervisors, software developers. All of these folks need to be in on the communication loop. The key difference, though, again, if you look back on our first video about responsibility and accountability, management is responsible just as much as anybody else for upholding quality, but really management, this also includes executive level, board level folks. They're truly the ones that are accountable for ensuring that there's adequate funding and resources for quality initiatives. This can range anything from training seminars to actual reviews of current processes, especially sometimes processes that might be serving, instead of improving quality, actually serving as a bottleneck and reducing innovation. So it's very important that we differentiate again here the difference between accountability and responsibility. Accountability, you can only have one. Responsibility, you have many. All right, and I think that just one more point on the cultural side of things. When we talk about quality and some of these quality principles, you'll notice that at the forefront of some of this is um, really the interweaving of other project management philosophies and principles. One, not the least of which, is continuous improvement, and TQM, as well as quality management overall, does mesh very nicely with continuous improvement. And again, there's a very big difference between continuous improvement and innovation, which is the rules that applied before no longer apply, but it's still the same game, right? And culturally, when we talk about big time producers, at least here in the US, there's a very strong corporate culture of seeking short-term gains at the expense of long-term gains. And by gains, again, it's not just financial, but overall, right? So when we talk about success indicators, employee retention, customer retention, ability to adapt and innovate. And it's really primarily what has set the um, international competitors aside, and uh, to really shine through when we look at U.S. manufacturing businesses versus Japanese automotive manufacturers. It is because of their long-term dedication to principles of quality and quality management, and it's primarily because their philosophy takes on a long-term approach of long-term gains as opposed to short-term gains. And I think a lot of that, interestingly enough, behaviorally, when we talk about delayed gratification and the makeup of brain and brain chemistry, it's very fascinating how that plays into effect. And I'll dive a little bit into that when we do our Tuckman model of group development presentation next time. So is the customer always right? Well, sort of. So in quality, we have these two major concepts called fitness for use and conformance to requirements, right? Does the thing you deliver truly solve the underlying issue? Does the thing work properly? And basically, does it do the right thing and does it do the thing right? Is what you are trying to answer when it comes to quality, both with a product as well as a service, right? Because again, quality is far more than just a delivered tangible product. Um, and the important part here, again, just as a reminder, is every project has a sponsor. Even though quality is not present just on a project to project basis, it is in fact uh, on everything else, which everything else in terms of project management means operations, right? So outside of project work, quality is still equally as important. And it's just a good reminder here to know that every project has a sponsor, and the sponsor is just as equally responsible as the team members doing the work for ensuring quality. It's a huge balancing act if we remember our iron triangle, where we have scope, budget, quality in the center. Those are very, very important factors and still at play here. And let's see if I had anything else to add on to here. Nope, that's pretty much it. So let's go on. How do you measure quality? So there's special causes versus common causes. And of course, there's tolerances versus control limits. You can really go in a myriad of ways in how you present this data. At the crux of it really is about making sure that we have data, and how we gather the data is also equally as important in terms of quality to then be able to make decisions to help improve quality, or if we're going to take a risk decision on the quality and say, you know what, yes, we acknowledge that it is a certain degree of quality, we're going to go with it anyway, consciously aware of the cost to the business, both in the short and long term. So that's why one way we can visualize this type of quality data is through matrix diagrams, scatter diagrams. Another way you can measure quality is through audits, which would be an external vendor coming in. Another way, right, when again we talk about quality as design for X, if we look at, Toyota as an example, they're designed for X priorities. You can't possibly design for all of them, but we can surely say that for a manufacturer like Toyota, they absolutely prioritize designing for serviceability, designing for cost, right, designing for assembly, and maybe not necessarily designing for some of these other factors here. So um, just to uh, really go back on special and common causes, just as their name suggests, when we talk about special and common causes, we're really talking about the Pareto rule, 80-20 rule. So 20% of something might be causing 80% of our problems, or 80 and vice versa. Common causes are things that are just a dime a dozen. Sometimes you can take a risk on those if it's like a web of a material and you see a particular common issue on the web, but it doesn't actually present a problem when the good end finished good goes to the customer. You can take that as a uh, accepted quality issue. There's also tolerances, right? Tolerances are things you can work with. That would be an example of a tolerance versus a control limit, where you have to stay in a particular certain range. And if you don't, then what that means is regardless of what your customer, is looking to actually buy from you, it doesn't matter. You won't even be able to get to that point if you're not able to maintain control limits. And then of course, with control limits, you're getting into statistical process control and issues of variability, and how do you properly manage those sorts of things. A good framework really to also measure quality is what is also sometimes referred to as the cyclical economy, and in the PMI world, they call it SIPOC, supplier inputs, processes, outputs, customers, and it's basically a visualization of how the flow of raw material as well as data. We're not just talking about tangible materials here. We're also talking about intangibles, right? This is where digital transformation would be critical, because having this data ecosystem in real time and being able to then historize, connect, collect, store, analyze, and visualize is critical here. This is just a framework showing you how the things you get from a supplier eventually goes through your entire plant to then deliver a outcome excuse me, an output to your customers. Very, very well connected to the cyclical economy. How else do we measure quality? And one way is Kaizen, which is again continuous improvement. It strongly follows the plan, do, check, act. And again, what's important to keep in mind here is Kaizen, however one you wish to pronounce it, is you are making small changes, and it is in a process for a very specific product at a very specific point in time for a very specific issue. It is not this blanket statement that continuous improvement is applied to uh, every aspect of the business. It's actually not meant to be used that way. It's meant to be used for a very specific issue at a very specific point in time for a very specific product on a very specific line, which again, while you might be making that product in similar lines, it does not necessarily mean that the issues that line faces are the same issues as another line faces. There's also the just-in-time approach, and essentially, especially as folks nowadays are trying to strive for a digital twin of their organization. Generally, inventory is seen as bad because you want to prevent waste. But really, the takeaway here is the only way you can possibly do that is if you have a truly interconnected data ecosystem, right? Going back to not only the cyclical economy, but from the framework we were just talking about before, having data from your supplier real time so you can see potential issues they might have had as they were generating the raw materials, as well as potentially issues with shipping said raw materials. There's also standards. Um, so this is getting into the auditing and regulatory compliance side of things. The biggest one is ISO 9000 for medical manufacturing. And essentially, it's documentation. But again, as we talk about documentation and data, it is really in the perspective of digital transformation, right? How do we leverage the unified namespace to make this type of uh, level of quality achievable and sustainable as well. Because once you achieve it, you want to sustain it. And then this is where you can apply Kaizen as you seek to sustain quality in the realm of data integrity for a particular product over the long run, right? This is where you would apply continuous improvement on that particular product and seeing how that particular data flow, whether there's any potential improvements uh, there or not. And of course, there's also statistical analysis. One tool in particular is statistical independence, right? Are the outcomes of two, three, four, five processes dependent or not dependent on each other, or to what degree are they dependent? There's again, when we talk about measurement, there's a analytical technique uh, with mutually exclusive, right? We mentioned this a little bit ahead. To what degree are they dependent, and also is following one process, then does it mean that you um, are not dependent on anything else at all, right? So, for example, if you're making some some caster wheels for a chair, does that really have an impact in when you are producing a particular slurry to be used for another product line? Do they actually interfere with one another? We're talking about attribute sampling versus variable sampling. So this is a really important, right? Because when we talk about attributes, what this means is we're talking about a binary, pass fail, true false type of scenario of a singular work of a singular result at a point in time versus variable sampling, which is how well something conforms to quality. And this would be something like the level of tolerances of batches in parts per million or billion versus attribute where you are taking a particular characteristic of of something at a particular point in time. Six Sigma, widely known, also very talked about, and for some industries they actually have higher levels of safety versus what industry says is the standard versus what the organization itself knows is actually best to follow. Aviation and pharmaceuticals do this all the time, where even though there's a 99.99999% level of cleanliness and a level of uh, uh, tolerance, really they actually go to one other decimal point because they know internally if they stick to just that 6 decimal points out, there's actually quite a bit of issues that occur that you and I as a consumer might not know about, but internally, when it comes to business processes, when it comes to vendor agreements and so forth, they know. And even when it comes to just raw material and overall inventory management, they know that this is a better approach, and it might not actually be that much more spending amount to maintain that level of quality. And then, of course, we have Ishikawa diagrams or fishbone charts. Essentially, it's the art of asking why, cause and effect, until you essentially get to the root cause, right? And equally important to remember here is correlation versus causation. And again, this is where having a truly interconnected data ecosystem is going to help you big time. There are various levels to quality. We hinted at this a little earlier, but essentially there's really four types, right? There's fixed by customer, where essentially you make it. You don't really have any level of controls internally. You don't really have a culture of quality, so you just kind of make it and you pass it on to your customer, and they tell you all the issues, and boy, will they tell you. Um, there's fixed by inspection. This is going up to the, holy grail and mecca of quality, where again, it's retroactive, but at least you're fixing it before it gets out the door. There's design for quality, where you have not only retroactive means, but you have other cultural and business procedures and practices and processes in place to assist with making sure that whatever good or service that you are producing, it is designed for quality. And when we talk about design for quality, we have the different parameters in quality that we design for, right? Are you designing for cost? Which means if you're designing for something to be made as cheaply as possible, that also might mean that your customer is getting it super, super far ahead than what another competitor might be able to deliver. And then there's something I like to call a quality neverland, which is everything, sort of instantaneously falls in place where all of the design parameters, like your design for serviceability, cost, etc., are all able to sort of instantaneously be optimized at every point in time. And I think though at one point where I would have called this Neverland, I think I see now it's actually more and more of the reality, especially when we talk about um, digital transformation and UNS architecture, where having the ability to see the data at every point in time and see history of the data is game changing, because now you can actually make informed decisions about what is the issue, what potentially might be the bottleneck, etc. So that Neverland actually is very, very, very much approaching closer and closer to reality, and there are already some very few, but some nonetheless, organizations out there that do this right now. And it's important to know that, the learning curve for many to get there uh, is exponentially going to grow as these folks continue to innovate. Um, and again, going back to Crosby's work, really, quality has more to do with morale, egocentrism, uh, dedication or learning or lack thereof, and understanding cognition than the actual products and processes themselves. You really need to understand that it's the culture that whether that sets whether the quality of your organization is either existent or non-existent, and the degrees to which are, and the differences in one company, even though they might be in the same vertical versus another that values quality and one does not, is very, very apparent to the customer. Even if you might not actually be collecting that data from your customer, you can bet that the customer themselves is gathering that data internally and making optimized business decisions off of it. As an engineer, let's talk about control charts a little bit. Control charts only inspect what your product, design, and process field are. So what it does not do is it does not, in fact, look at the previous steps that came into play to get to the point that you're interested in. And furthermore, just because something might say be almost perfectly aligned with the mean of your control charts does not actually have any say in the fact that it's of good quality. In fact, this is where, again, having applications in data science will clearly show that if your control charts are reading like almost perfectly on the mean, something is terribly wrong, because you don't know for sure whether you're actually reading correctly, um, or if you're what you're reading, even if it's actually saying it's correct and within control of your and within your mean, does it actually mean you're producing quality material, right? And that's not necessarily the case. One tool we have from data science is the rule of seven, where if we have seven sets of points that fall exclusively on one side of the mean, you investigate the validity and integrity of your data. Control charts are not the end all be all. So many engineers are hyper focused on control charts. They have their time and place, primarily for historical value, but they are not the end all be all. And it's important, and it's challenging because I remember when I was going through my engineering training, control charts were essentially, the gods that we were beholden to. And not only does it remove the critical thinking aspect of the job, but it also wrongly makes you expectant and beholden to just one and prioritize just one data point as opposed to, or one technique as opposed to a holistic approach and having many tools in your belt and utilizing a framework and many frameworks at the same time to really then come to an informed decision. The outputs of quality management, if you remember, I have a slide coming up where we look at the process groups, right? Uh, when you finish your plan quality management process, you're essentially identifying the specifications and quality and how they will be met. So basically, it means you're building your quality management plan and your quality metrics, right? And we talked about how to measure quality before, which we do in the uh, control quality, right, step. But now that we have the plan, we were managing quality. So this is really not looking at just the product design. It's actually looking at the process improvement, which is to say the thing that's taking place to actually make the thing itself. So these are things like change requests internally as well as from customers, as well as the types of test and evaluation documents internally as well as externally that we use not only to for the product, but again for the process. And then, of course, finally, we have controlling quality, right? Where again, everybody is bound to have the need to retroactively look at quality issues. And so, quality control measurements, right? And verified deliverables. In here, what this output in particular, what it actually means is that the customer is getting the thing they asked for and it's doing the thing right. So that's what verified deliverable means. It does not mean that the project is closed by completely the opposite. In fact, this is not the final step, as we will see here again in our visual for outputs of quality management. So you can see when we talk about quality, right, we are roughly around this point in our process groups, and we have monitoring, controlling, and closing to do. So never confuse an output of a particular step of a process group with the closing of a project. Project close always comes at the end. So let's talk about the agile approach to quality, right? A lot of folks will often say, well, is quality even relevant in agile? Um, and it's actually a very silly and totally nonsensical question to ask when you think about it. But many people, I think, naively do, and I want to take the time to address why they might do, right? And I'll do that by actually painting a picture of what it's like for setbacks in the traditional style of project management that really deters people away from even having any sort of conversation about quality. It's very similar to the conversation of cybersecurity. A lot of organizations think, well, if anything's a security risk, then automatically that deters any movement in innovation and transformation and disruptive and transformative leadership. And understandably so. People often wield that same quality hammer where they will say, well, this particular thing that you're trying to propose is not going to meet XYZ quality metrics, so therefore it's not going to be something that we do in the name of quality. It's really the same level of stagnation hammer that they're using instead of a band hammer. It's stagnation hammer, as I like to call it. Um, And basically, what it means is there's a strong tendency in traditional project management approaches to over enforce and apply strict processes at the expense of innovation, and oftentimes at the expense of actually achieving a certain level of quality that these processes are setting out to achieve. I cover this in another video titled "The Paradox of Efficiency," not just in consumption of raw materials, but to what degree of continuous improvement are we seeking out to make something that much better and of higher grade quality, and is it actually achieving a desired outcome where, is this level of increased quality actually worth, the XYZ amount that we put into it or not? Or is it just something that is, it might allow us to consume just slightly more, but at the expense of vastly more, say, customers, employee turnover, and so on. The agile approach really it still values quality. It's just the way in which quality is done is different. The biggest one, absolutely, as we can see here when we talk about the four values of agile, is they value individuals and interactions over processes and tools. So again, the incessant need to slap a process on everything as if, you know, as if by adding five or six processes is going to automatically cure your business needs is just ridiculous. And Agile very clearly sees that, especially when you have complexity in your project, right? If it's something as simple as you make a hammer and that's all you make is just a hammer, and this hammer is exclusively for use to DIY customers who are not doing heavy industrial grade work, and these hammers, are not going to be left outside to expose to the elements, and they might not need some of the other uh, bells and whistles of a hammer that, say, a carpenter might use, like attachments to easily connect to a tool belt and so forth. You know, that's one thing. But when you have complex, data structures, ecosystems, and systems integration work, the amount of processes you're trying to implement oftentimes will actually do the opposite, where it's going to be a detriment instead of serve to improve not only your bottom line, but the product and service you're looking to deliver. Working software over comprehensive documentation. Covered this in the project management video, but basically, right, traditional project management, it's you have 12 management plans. You do all that planning right up front. Literally no work gets done at this point. You're just planning everything, and you're hoping really that everything will go according to that plan. But Agile uh, does not value that, and they instead say we're going to deliver this functional part to the customer, and then we're going to quickly get feedback from them, and then we're going to take the feedback and make our product better and continuing that value stream. Customer collaboration over contract negotiation. This is especially present when we talk about raw material vendors. Um, you can have a raw material vendor, for example, that say might cost you less, per volume weight over time to get, but the things that you're actually getting at the end, whether it be, the vendor has no sort of data ecosystem, or even if, say, their raw material is of similar quality to another vendor, but that other vendor had checks in place to keep their customers happy. They frequently check in, they share data with you. Um, Agile much more values that open, transparent line of communication as opposed to contract negotiation and setting things in absolute stone without any level of flexibility and adaptability, which again feeds back into the final point of responding to change, right? This is so important. I can't even stress this enough. Uh, just in time is a approach to supply chain and inventory. The thing of it all is that it is not the end all be all. It works for certain times, especially for seasonal items. However, just in time is not like this universal auto magical approach. What you actually need, especially with supply chain, is what sets apart customers like Amazon and Tesla is their ability to quickly change their supply chain approach, right? So they're not just sticking and leveraging just in time. They're leveraging other supply chain methodologies as well. And they're able to do that instantaneously as opposed to having to, you know, see and plan for 3 months before then adapting to the change. That's really what's key to success, not just to their success, but success uh, overall. You need the ability to change up that position and that strategy for your supply chain at any point in time, as opposed to saying we're just going to go, long for the next 10 years in this one supply chain approach. That's really at the crux of this. And the only way you can do that is if you have a truly interconnected data ecosystem that's open architecture, report by exception, right, lightweight. These are the things that really make or break companies. So this is really how agile looks to quality, right? It really sees the need and value of an omniscient and ever-present data ecosystem for which people and not just board members or C-suite can immediately pull data from to make informed business decisions about. And even if they don't have all of the data or a perfect amount of data, they can use computer science uh, frameworks to go based off of um, unknown unknowns, known unknowns, known knowns, that type of way of data thinking to then make a business decision that is at least grounded in some sort of reality as opposed to planning for something and then having to do the hard labor of readjusting after you see that your plan did not go, that nothing went to plan at all. But again, it's the cost there with traditional planning is 3 months of planning. You see how the plan works in 3 months, and then another 3 months to readjust. So really, you're looking at like 9 months in total to adjust and pivot. Whereas in a truly interconnected data ecosystem, you might be looking at 2 to 3, right? That's the difference. So we're approaching the end here. Like to do a little quiz, and I'll try my best to shuffle back to the slides for some of these. But in this case, I think these are pretty straightforward. But going down the list here, right? Who's responsible for quality? Well, everybody is. Everybody in the organization absolutely is. Um, and this is again remembering the difference between responsibility and accountability. And when we talk about who's accountable for quality, right, this would be the uh, folks in management. And management is not just, shift supervisors. Management really is anybody who is at the executive level as well. How much does quality cost? Totally free. This is where design for X, the design for X technique comes into play. And probably my favorite is I'm a smart engineer who thinks they know everything because I'm special like an escape quality. True or false? Absolutely false. Although I will say probably when I was in my earlier years of school, I thought the opposite. But you can't, right? Even if you didn't design for X factor and quality, it designed for itself in the way that you built it. just because you don't have something in mind does not mean that that influence is not being exerted on it, right? That's the thing with quality that Crosby absolutely showed. Um, it doesn't matter if you don't take it into account. It's still being taken into account. Overall, there's universal forces at play, and it's your job to remedy and reconcile with these, right? And just some further reading materials for you there. Crosby has two books, my favorites. Quality is Free and Quality is Still Free, which I think is hilarious as a title to a follow-up. Really, um, really wonderful read. It's like equal parts, uh, like actuarial science and raw statistical analysis and heavy number crunching, to also many cultural analogies and storytelling type of deal. So highly recommended. Of course, there's the PMI. Uh, there's a PMBOK guide, which I think now also comes with Agile Practitioner's Guide. But there's also one of my favorite books recently, which is Algorithms to Live By. Again, not sponsored, by Brian Christian and Tom Griffiths, which really dives into computational science, um, and ways of thinking and applying these to human behaviors. Definitely worth a read. I think it's also available as an audiobook. So I hope this was helpful. Um, if you have any feedback on, what I can do to better improve my presentations, if you think they're too long, if you think they're too short, would greatly appreciate it. But if you made it this far, thanks, and keep an eye out for that upcoming video on the Tuckman model of group development, and I will see you at the next one. All right, guys. Peace.